Good morning students, how are you? Hope you are all in the pink of health. I am Atul Rai and you are watching bond making and bond breaking channel. So today I am going to discuss with you about the physical properties of carboxylic compounds. Okay, so this video is not so longer as compared to the others. So let's start without delay with optimistic energy. Let's go. So, firstly, on physical properties, I give you the idea which compounds gives you smell. Which compounds gives you smell? Just think HC HCOOH. This is formic acid. This is formic acid, and you get the next CH3COOH. This is acetic acid, and third one is CH3CH2COOH. This is propionic acid. So why it is propionic acid? Due to the presence of 3 carbon atom. Okay, so carbon 1 to carbon 3. Carbon 1, on formic acid the number of carbon equal to 1, on acetic acid number of carbon equal to 2, and on propionic acid number of carbon equal to 3. So carbon 1 to carbon 3 shows gives you the smell. Gives you the smell. But then carbon 4 to others, it does not give you the smell. It does not give you the smell. Carbon 4 to others, carbon 5, carbon 6, carbon 7, it does not give you the smell. So carbon 1 to carbon 3 gives you the smell, but carbon after carbon 4 it does not give you the smell. So this is the first physical properties. Physical properties means the properties which you feel or which you can observe by physically. So firstly, smell, and the second one is solubility. And the second one is solubility. So next, solubility. Solubility means the tendency to soluble in water. The tendency to soluble in water is called solubility. So if we compare its solubility, then formic acid, that is HCOOH, formic acid. Okay, this is formic acid, and then you take CH3COOH, that is acetic acid. Formic acid and then acetic acid. After this you take CH3CH2COH. This is propionic acid. As the carbon number 3, this is called propionic acid, and then you take this CH3CH2CH2COOH, 1 2 3 4. This is butyric acid. So the number of carbon 4, as it is 4, it is called butyric acid. So the carbon 1 to carbon 4, what I say, carbon 1 to carbon 4, this is the carbon 1 and this is 1 2 3 4. Carbon 1 to carbon 4, it can dissolve in water. What I say, it can dissolve in water, but after 5, C5 to others cannot dissolve in water. Okay, why cannot dissolve in water? Because firstly we see that why the carbon 1 to carbon 4, that is formic acid to butyric acid, can dissolve in water. So what is the reason behind this? The reason is it can form hydrogen bond. It can form hydrogen bond with the water molecule. What is it? It can form hydrogen bond with the water molecule. As it is formed, it can form the hydrogen bond. It shows the solubility nature on water. But carbon 5, when it goes to carbon 5, that is 1 2 3 4, so this is butyric acid, then the pentanoic acid, that is CH3 CH2 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 COOH. This is pentanoic acid. 1 2 3 4 5, this is pentanoic acid. From pentanoic acid to others, it cannot give you, it cannot show the solubility nature on water, because this part is non-polar. As it is non-polar part, when non-polar part increase. When non-polar part increase, it means solubility decrease. Okay. So from pentanoic, the non-polar part increases, or this hydrocarbon part increases. As the hydrocarbon part is large, it's insoluble in water. So solubility is depends on the polar or non-polar compounds. Its characteristic is it is polar or it is non-polar, as well as it depends upon the hydrocarbon part. If the hydrocarbon part is longer, so it may be insoluble in water. For finally, it is insoluble in water definitely. Okay, this is solubility. And now it's boiling point. So the third physical properties is boiling. Third physical properties is boiling point. Okay. So if we compare the boiling point with alkane, take alkane. Okay. Then ether. So firstly alkane, secondly ether, thirdly carbonyl compounds, aldehyde, ketone, acyl chloride, carbonyl compounds, then carbonyl compounds, and then alcohol and carboxylic acids. Alcohols and carboxylic acids. Okay. You want to compare its boiling point, which shows more boiling point. What will be the order of boiling point? You have alkane, you take ether, you take carbonyl compounds, you take alcohols, and you take carboxylic acids. So what will be the order? The order will be this. So the order will be alkane to carboxylic acid. Carboxylic shows higher boiling point as the compare of alkane or as the compare of others. Why? From alkane to ether. Now from alkane, you see that on alkane it shows only van der Waals force of attraction, weak van der Waals force of attraction. Okay. On alkane, van der Waals force of attraction is occurred. On ether, van der Waals force of attraction is occurred, as well as the dipole moment is occurred. So here only poor dipole attraction or weak van der Waals force of attraction is seen. On the other hand, on ether dipole-dipole attraction, weak dipole-dipole attraction and weak van der Waals force of attraction is formed or is occurred or is shown. You can see in this compound, on this compound. And on carbonyl compounds, the dipole-dipole attraction is more stronger compared than ether. What I say? Dipole-dipole attraction is more stronger compared than ether. Then we come to the alcohols. On alcohols and on carboxylic acids, if we compare those two compounds, we get that carboxylic acid shows more boiling point. What is the reason behind it? The reason is the hydrogen bond of alcohols. The hydrogen bond on alcohols is weaker than the carboxylic acids because it can form dimer. So how it can form dimer? If you take acetic acid, that is RC double bond OH, you take this acetic acid, so it form there RCOH, COH, so the bond. So in this way carboxylic acids can form dimer. As it can form dimer, it shows more boiling point because to break this bond the required energy is high. As the required energy is high, it shows you the highest boiling point compared than others. Okay. Very simple and very important. Now finally, so give you the next physical property, that is melting point. Okay, melting point. You should remember that boiling point is always depends upon molecular weight. Okay, melting point also depends upon molecular weight. Melting point also depends on packing. If packing is good, or well packed, tightly packed, it gives you high melting point. Okay, now take problem that helps you to understand the question. So the problem is, if you have CH2, CH3, CH2, CH2COH, or you have CH3, CH2, COH. You have this compound and you have this also. So the number of carbon equal to 4. Here the number of carbon equal to 1, 2, 3, 4, 5. Okay. Here the number of carbon equal to 5. So it gives you so where the number of carbon is even, number of carbon 1, 2, 3, 4, where the number of carbon even, and here the number of carbon odd number of carbon and even number of carbon. It's a factor, and another factor is the CH3 and COH on the opposite position, where the CH3, COH and COH on the same position. So its boiling point as the intermolecular force of attraction, intermolecular force of attraction, intermolecular force of attraction. What I say? Intermolecular force of attraction. Where is the intermolecular force of attraction is high, it gives you high melting point. So this product gives you high melting point as compared this. Firstly, it has even carbon atom, so the packing of this compound is very good. First point, and the second one is the intermolecular force of attraction is very high on this compound. As the intermolecular force of attraction is very high, it gives you the highest is a higher melting point compared than this. Okay. So those are the common and important physical properties. Hope you understand on the topic of properties of carboxylic acids is very essential, and it helps you to create your base, and obviously it helps you on board exam as well as the NEET and JEE. So keep studying, all the best, and take care of your health. See you soon. Goodbye.